Hello everyone, I just thought I would show you what I'm up to today because I've just bought this tape deck from eBay as a refurbished, fully tested and fully working tape deck. It's a Sony TC-K611S. It's a pretty late model of the generation, one of the good ones. It's got the three Dolby modes, B, C and S, and you can see you've got the bias and control level of the recording, so that in record mode you can put the tape in, press record, press calibration, and then you can adjust the bias of the recording signal and also the record level of the recording signal to optimize the performance of the particular tape stock that you've got. So you can adjust it up and set it up, make sure it's set up correctly according to the user manual. There's a monitor button which just connects the DIN inputs on the back with the outputs, so it loops the signal through to the output, so you can see what the source of the signal for the cassette deck is doing by monitoring via the output, i.e. listen to it on the speakers. So that's just a bypass button really in the play mode. And in the record mode, because this has got, so it's three heads, it's got a erase head, primary record head and a playback head. So in the record mode, if you press the playback, you get to listen to what's just been recorded maybe an inch further up the tape, so you can actually listen to what the recording sounds like in real, well, more or less real time, not quite real time. What else have we got on here? We've just got all the normal controls, you know, the track search and all the rest of it, counter, memory reset and all that stuff which you're all fully aware of if you've ever seen a cassette deck before. So I'm testing this today, and what I'm testing it for is, when I tried it out, the sound quality in terms of the frequency response sounds good, but the wow and flutter didn't quite sound right to me. You know, the wow and the flutter, if they're not right, then you can hear some sort of frequency aberrations on the recording, so it's not a good thing. You want very low wow and flutter to give you a reliable playback of what you recorded in terms of speed and frequency and stability of the frequencies. So this, I think, is spec'd at 0.1%, plus or minus 0.1%, but I've never seen one perform to that. They normally run at about 0.2%. So to measure the wow and the flutter, we use this piece of equipment over here. Okay, so this is the I'll read you this name because it's quite funny. Well, I think it is. So it's a SHCWANKUNGSMESSER ME102B, made in Munich, very reputable piece of kit, works beautifully. I've owned it for quite a few years and tested out many tape decks with it, and it's lovely. It does a great job of telling you whether you're wowing and fluttering properly within the specifications. Don't ask me whether you can hear the wow and flutter and how bad it is. Depends on, particularly on the type of music you're playing. Anything with prolonged, things like violin notes, you can think you can hear wow or flutter, but it might actually be the musician doing a bit of vibrato on the strings. So anyway, on this side here we have the drift meter, and that's really the wow meter, okay, on this side, and that's measuring the deviation from the set frequency over a longer time period. That might be something like, well, I'll just give a better explanation actually. So the wow is a low frequency cyclical speed variation, which is very common on vinyl records. You know, for example, if you've got a hole that's off center in the middle of your record, then you will get a speed variation of the stylus on the record as the thing is running off center. Or if you've got a warp disc, you've got the same thing, because it's traveling a different distance to what it should be, because it's going uphill. So it's going at a diagonal to the plane of the turntable. And then on this side you've got the flutter. That's measured in up to plus or minus 2%. And this side you've got the flutter meter, as your flutter meter, and that is actually measured. It's got two scales on there, 0 to 1 and 0 to 3. 0 to 1 would be a 0.1% or a 1% range, and the 0 to 3 can be the 3% testing range. And this is the much faster frequency variation, you know, typically caused by a worn tape machine capstan, or a lumpy pinch roller, or dirt on the capstan, or anything like that, or, you know, power supply variations, or bearings in the motor going strange. It's the far higher frequency fluctuations. It's called Flutter, okay. So as I say, it's spec to be plus or minus 0.1% on this particular tape deck. So if I just zoom out on those controls, you can get a better idea of what we're talking about here, how this thing works. Down in this corner we have the output, which is a 3150 Hz 0.4 volt, 0.4 volts RMS signal, and it's being fed out there. And then on the other side we've got the input, the Eingang, which is the signal coming back from your tape deck. At the moment it's on monitor, it's on source, so at the moment, because it's set to source, the output is coming through the tape deck and straight back in the input, so there should be no variations that we can see. Now we've got a test button here, and if I just press the test button, you can see that we have 0% drift and 0% flutter, and if we put it on the 0.1% range, it'll kick. And that'll give you an idea of the time constant of the frequency to voltage converter. What it does is it's got an instantaneous frequency to voltage converter, and the output of that is fed into an integrator, and then the outputs of those two circuits are compared, and then you can see the variation in frequency over maybe a short time scale. I'm not quite sure what the bandwidth is, but it is stated in the test specification for the official DIN or JIS standards. All right, so in the test mode, if I just kick this, you can see I can move the drift up and down, so I'll set the drift to 0 to calibrate it, and if I just let it settle over there on the flutter meter, if I just kick this, a quick twist like that, you'll get an idea of the bandwidth of the integration time of the actual discriminator on the receiver side. So I'll just click that, you can see it quickly drops back to 0. So let's set it to 0. Alright, now we can undo the test button down here. I'm just unpressing, so I'm just removing test mode. You'll see it kick and then get back to 0, and you can introduce a 0.1% test flutter, plus or minus, and you can see the meter's gone up to 0.2, so that's working. And then you can add a 2% wow. You see we've got a 2% wow there. You see, even though the speed is running 2% faster than it was, so say your playback time is faster than 2%, faster than the actual reference speed that it should be, the flutter is still 0 because it's a constant 2%. So you can add the wow and the flutter. So if you saw that on a deck, you would say it was 1.9% wow and plus or minus 0.1% flutter, okay? So I'll take them off test mode, I'll take the test buttons off, and it should go back to 0. So the output down here is connected to the input to the tape deck, and the output from the tape deck is connected to the input of the instrument, okay? So if we just go back to the tape deck now, we're going to do a wow and flutter test. It's set up, it's ready to go. Let's just go and see what happens. Right, so at the moment we're on source. So that little red light in there says source, is illuminated. So the input is going to the output, that's fine. We don't want it on source, but so we take the source off the monitor. Okay, so now we're not feeding anything to the wow and flutter meter. Right, so we've got it set up. The signal's being fed in. If we just press the record button, we can see the level is being fed into the left channel. So this is not a stereo wow and flutter, it's a mono one, but you can test the channels independently. If one's working, I've never seen a deck where the other one was playing up at all. And then you can adjust the level to 0 dB with the record level control on the front of the tape deck, which is what I'm doing there. Out there, it'll do. And then if we just press record, it's now recording the test signal. Now the cool thing about this is you can see at the moment we are on source. If I just press this button over here, the monitor button, we are monitoring the tape. Right, so it's being recorded here, being played back there, fed out into the meter. And then if we return back to the meter, we'll see what sort of performance we're getting. Alright, so if we do a close-up on the drift, or the wow, you can see it's hovering about 0, so the speed is about right. There's a minor variation there. That could be the pinch wheel, because we are monitoring the actual recorded signal from the tape now. This has gone through the tape machine, put onto the tape, came off the tape, fed into our test instrument. So we've got a tiny bit of drift, but if we go across to the Flutter, actually before I do that, what I should do is stop the tape. You can see on the 0.1% range we have more than 0.1% flutter going on here. So if I just press the 0.3% flutter button, so we're going on to a different range of fluttering now, and there you can see the flutter on this tape deck, and it's plus or minus, well, it's bad, isn't it? It's pretty bad actually. I thought I could hear that. And if you watch it, is it doing a cyclical thing? Yes, it is. But interestingly, look, the pinch, it's 1 5/8 inch per second, isn't it? And you'd think if it was the pinch roller, it would be going through a 1.5 second pattern on the needle. Interesting. Suppose it could be the pinch roller. Anyway, it's not good. It's not good. It's not fully tested because it's fluttering like a, well, a fluttering thing basically. Disappointing. So what I'm going to do, I think initially, is this has got new belts on it. I checked, they look new. It can be caused by the belt if the belt is a little bit, you know, loose or stretched or not the same constant tension all the way around. It can do strange things, and of course dirt and build up on any of the drive pulleys will also cause that too. Dirt on the pinch spindle, or a clagged up or knackered old pinch roller. Don't forget these pinch rollers are polyurethane rubber, and that's the stuff that just disintegrates due to the ozone in the atmosphere. Eats away at the rubber, and the belts just turn into a gummy mess after 20 years and wrap themselves around the spindle in a self-amalgamated blob basically. It doesn't look like a belt anymore, it's a lump of sticky rubber compound almost, and you've got to clear all that off. So the first thing I'm going to do is whip out the pinch roller and have a look at it and see what sort of condition it's in. Back in a moment. Rewind the tape. Rewind the tape. Tape is rewound. Now if I go and press play, this is the straight playback without the monitor. So this is what's coming out of the machine now on playback. So if it's a mechanical issue, you usually expect the playback flutter to be the same as the actual record flutter. You can say it is pretty much. Yeah, it's just the same, isn't it? So that's what we've got. So now I'll take the pinch roller out and have a look at it. Right, so here's the old pinch roller. You can see it's actually slightly domed. You can see that. It's not quite flat, is it? It's had a hard time. It's very hard. Very hard indeed. It's gone rock hard actually. But if you look at it, you can see the surface is all over the place. It's not, it's got a scrub mark there, look. You can see that shiny bit. Yeah, so if you've got a cassette player that's a bit old, you could do a lot worse than just simply clean the heads and change the pinch roller. There's a big lump on there as well, you can see that. Yeah, so that's not going to be helping. It's very, very hard as well. It's not like a pinch roller. It should have a nice plain napped matte finish on there and be nice and uniform, and also be flat across the edge. It looks like it's slightly domed to me from what I can tell. Anyway, back to the I'll put the new one in and we'll test it. You saw the old pinch roller. New one is now fitted. If I just press record, now, and switch from source to the actual tape, so you're listening to the tape. There we go. So you can see it's hovering between 0.2 and 0.25% wow and flutter, which is about average for one of these machines. A new belt might reduce it further, but for a belt driven tape deck, that's probably about all you're going to get. So we've made a significant improvement. We've done away with those big peaks up to 0.4, which was going off the scale of the 0.3% scale. So there it is. So the moral of the story is, if you're going to buy a used tape deck that's supposed to have been tested, just make sure the wow and flutter has been checked, because you might never receive it in a condition where it was as it left the factory. I think if I change the drive belt again, you'll get a slightly different reading. All drive belts give a slightly different reading, but you know, a drive belt system, that's about as well. That's about as good as it's going to get. So I hope you enjoyed that. Anyway, so if you can just leave us subscribe if you're not subscribed. If you are, thank you, and leave me a like, because I like likes. Thanks very much.